Hey kids, how's it going? All right, today we're actually going to do an assignment. This is a little refresher from the other day in case you didn't watch the video because, why would you watch the video? Because, whatever. Anyway, we talked about, again, compression ratio. CR, if you will, is equal to the volume of the cylinder plus any volume of the combustion chamber plus any volume of the piston dish. And technically there's another piece too, but we'll leave that off for now. We'll wait until you're little bigger kids to worry about that. It's not a huge deal. Once you understand the basics, it's just simply a matter of adding on a little bit extra. So later on we'll talk about the head gasket thickness, and if you put a bigger head gasket in there, you can actually reduce the compression ratio. Okay, and it also has to do with the piston if it doesn't come flush to the top of the cylinder head, to the cylinder. But whatever. We get into that more in depth later. Once you understand the gist of this, is really straightforward. Okay, so Mr. Groom's going to turn the page here. We're going to do an example of one. So let's just say, hypothetically, Mr. Groom has an engine that is a V8, just for fun. By the way, on the assignment tomorrow, Mr. Groom, does it matter if it's a V8, straight 8, radial 8, anything of 8? Not really. It just has to do with 8 cylinders a bit. And if it had a bore of 3.96 and a stroke 4.25. You're like, whoa, Mr. Groom, the bore is smaller than the stroke. That's right. This is an under square engine. There you go. Cool. What am I supposed to do with that? Hold up, bro. I ain't done yet. So I'm going to tell you what the combustion chamber volume is here in just a minute. I'm going to tell you what it is. And whilst I'm at it, I'm also going to tell you that it has flat top pistons. Okay. Now, one moment, please, whilst I get my calculator and everything fired up. I'm back. So, the combustion chamber volume is, and for this case, 7.5 cubic inches. Now, bear in mind that on the assignment, I may very well give it to you in cubic centimeters. So let's just for fun, let's just do this. All right, let's come in here and let's go, Mr. Groom. Let's do 7.5 inches cubed to CC. Nope, I have no idea what that says. Betsy doesn't understand me. Betsy and I don't get along. It makes me so sad. 7.5 cubic inches to cubic centimeters. Mr. Groom, couldn't you just type it faster? Probably, but I'm having too much fun. Oh, look at that. So this one has 123-ish cubic inch or cubic centimeter combustion chamber. Okay, combustion chamber. Now, I say that because on the assignment, I may very well give it to you in cubic centimeters. It is a huge deal to make sure that you are all in the same units. Because my bore and my stroke are in inches, my volume of my cylinder is also going to be in inches cubed. So I'm going to make sure that this guy is also in inches cubed. So here it is. Pi times 3.96 square divided by 4 times 4.25. That is the volume of my cylinder, one of them, plus 7.5 divided by 7.5. Do the math, Mr. Groom. Hey, look at that, 7.97, or roughly 8 to 1 compression. 8 to 1. Basically 7.97. Mr. Groom is not going to get angry. Of course, I will grade it. And if you put 7.97, I'm okay. If you put 7.98, I'm okay. Whatever. Okay, I am pretty comfortable with going back over that. We'll probably say something like round it to 2 decimal places. So if I was doing that, I'd do 7.98 to 1 or something like that. Okay? So I'll practice what I preach there. Okay? Now, is that doable? Yeah. We said that traditionally 7.5-ish is very low. Okay, up to maybe as high as 10-ish to 1. That's from the factory. If you built your own car, you might get yourself a 12 to 1. That'd be pretty good, but it'd be hard to drive that on regular gasoline. You need to run better gas than that. On this assignment tomorrow, I might also ask you, what is the displacement of this engine? Displacement. And so, of course, that'd be pi. Wait, it'd be this formula right here, this first part. That's right. Times 3.96 squared divided by 4 times 4.25 times 8. Because, of course, it is an 8-cylinder engine. And so 3.14 times 3.96 squared divided by 4 times 4.25 times 8. 418 cubic inches, roughly. That's a biggin. She's a biggin. Nice. Let's do another one, Mr. Groom. Okay, one moment, please. Okay, here's an engine. It's 3.71 bore, 2.98 stroke. Hey, Mr. Groom, does that mean it's over square because the bore is bigger? That's right. Good job. I'm proud of you. Good job. Give yourself a pat on the back. All right. Cool. Well done, friend. All right. Now, Mr. Groom, let's find the compression ratio. All right, cool. Let's do it, yo. Pi times 8.71 squared divided by 4 times 2.98 plus, oh no, this is all in inches. Why, that's in cubic centimeters, Mr. Groom. We better convert it. Oh, look, I already did. 67 cubic centimeters is 4.1 cubic inches. Did you do that behind our backs? I did. That's what you do when you're a teacher. You figure problems out. Oh, look, when you divide it out, look what you get. Lo and behold, you get about 8.85 to 1 compression ratio. Slick as a whistle, man. Slicker than a whistle. By the way, flat top pistons here. That's what we did it as, so I'm going to go ahead and put it back on there. What is the displacement of said engine? I don't know. Let's find out. Pi 3.71 squared divided by 4, 2.98 times 6. I'm going to die. Stupid nose is driving me bananas tonight. It's like I'm sitting next to a field of pollen of some sort. And it's wintertime, which is just kind of dumb. 193-ish cubic inches. All right. Sweet. Mr. Groom, do another one. Do another one. Oh, all right, fine. This time, let's do a metric one. All right, one moment, please. All right, here you go, friends. Ooh, Mr. Groom, it's metricized. It is. Ooh, it's a square engine. What does that mean, Mr. Groom? It means the bore and the stroke is the same. Now, be careful. I tried to screw with you here. Don't let me mess you up. To do our calculations, we want to be in centimeters. So remember, that moves the decimal over one spot. So 89 millimeters is 8.9 centimeters. Don't let that fool you, friends. Don't let it happen to you. Don't be that person. The compression ratio is equal to pi 8.9 square over 4 times 8.9. Notice I'm not converting these. They're already in cubic centimeters. And these are in cubic centimeters. Everybody's in cubic centimeters. Let's do it, yo. Oh, I did it. It's right here. Bam. 11.25 to 1. Will this engine run? Yeah, it will. Will it need higher octane gas? Probably. Yeah, it probably need a 93 octane gas at the pump. Otherwise, it's probably not going to run right. It's going to have some problems running. But yes, this is a very doable engine. Again, it's a square engine. If I were to find the volume of said engine, watch Mr. Groom come up here and grab this fella, times 8, right? 4427. This is the displacement. That's in cubic centimeters. That's nice. No one cares. So we convert it to 1, 2, 3. 4.4 liter engine. Boom. And Bob's your uncle. All right. That's the game. That's what we're doing. You're going to be playing this game yourself today on the assignment.